Alright, consider this function. X can't be 1. Sketch of part of the graph is given below. The line AB is a vertical asymptote. Point P is a point of inflection. Write down the equation of the vertical asymptote. It's when the denominator is 0, which is at x equals 1. Find H prime. So if we do quotient rule, du is just 1. dv is 2, x minus 1 to the 1 times 1, because of chain rule, but that doesn't change anything. So h prime is going to be v times the derivative of u, which is just 1, minus u times the derivative of v. So I'll just write it like this. And that's all over v squared. So x minus 1 squared is x minus 1 to the 4th. We need it in that form. So if we expand this out, and then it's going to be minus, let's put plus a negative. All right, so minus 2, and then I'll just expand this. So x squared minus 3x plus 2, and then we're going to have x squared minus 2x squared, which is negative x squared, negative 2x plus 6x, which is plus 4x, and then negative 1 minus 4, which is negative 5. Take out the negative, and then, one sec. So that factors to x minus 1, x minus, no. So 5 and 1. Okay, this should be plus. I found my mistake. So that's 1 minus 4, which is negative 3. So this is positive 3 here. So that factors to x minus 1, x minus 3. And we have x minus 1 to the 4th. So we're going to have negative. One of these cancels. So negative x minus 3 over x minus 1 to the 3rd. And then distributing the negative, we'll have 3 minus x. So a is 3, and n is also 3. Okay, given that h double prime is that, calculate, so they don't make us do the second derivative, thankfully. Calculate the coordinates of P. So points of inflection, and they're telling us P is a point of inflection, so we're not going to have to check, but we set it equal to 0. Cross multiplying by the x minus 1 to the 4th is just 2x minus 8 is 0, and then solving for that we get x equals 4. And we could check on either side, but like I said, they tell us it's a point of inflection, so we don't have to. And we just need the coordinates. So we need the original function. Well, it's h at 4. So 4 minus 2 over 4 minus 1 squared. So that's 2 over 3 squared, 9. So the point is 4 2/9. All right, we've got g defined for negative 3 to 3. The behavior of g prime and g double prime is given there. Using the information above, in each case justify. So write down the value of x, for which g has a maximum. So we know that it's going to be here or here, because first derivative equal to 0 is a stationary point. So we know here negative gradient before, positive gradient after. That's a minimum. And this one is positive gradient before, negative gradient after. So at x equals 1, that is when g has a maximum. And that's because the derivative changes. So f prime changes from positive to negative. Okay, so B, on which intervals is G decreasing? So that's when the gradient is negative. So G prime is less than 0, -3 to -2, and 1 to 3. All right, C, write down the value of x for which the G has a point of inflection. Well, that's happening at x equals -1/2 because f prime, G prime, whatever, G prime, double prime, changes concavity from positive to negative. Given that G at -3 is 1, sketch the graph of G. On the sketch, clearly indicate the position of the max, min, and point of inflection. So if we have G at -3 is 1, and so we have that it's negative gradient until -2, and then it's a minimum, and then it starts being positive till 1, it's a maximum, and then it goes back. So at -1/2, so at 1, and then it goes like this. Oh. Wait a minute, because I'm not doing, I read -1, it's +1. Okay, so here it's going up. So at +1 here, it's a maximum. And at -1/2, it's a point of inflection. Okay, so min, max, and then it goes from 1 to 3, it's going back down. Okay, something like that. Okay, maybe these should be open circles as well, because it can't be -3 or 3. And let's just check. It's negative gradient from -3 to -2, and then positive gradient from -2 to 1, and negative gradient from 1 to 3. So that's good. And then we have concave up from -3 to 1, -1/2, and then from -1/2 to 3, it's concave down. So that looks good. Yeah, cool. Okay, consider this function. Find the derivative and deduce the monotony. Okay, so we've got u, v, and du, and dv. So we've got f prime. Okay, so v squared, and then v times du minus u times dv. So we can factor out an e to the x. So that's going to be e to the x plus 1 minus e to the x minus 1 over e to the x plus 1 squared. So this e cancels, e to the x minus e to the x, and 1 minus -1 is 2. So this is going to be 2e to the x over e to the x plus 1 squared. Okay, so this is going to always be greater than 0. Like if we set this equal to 0, cross multiplying, and then we'll have 2e to the x is 0, e to the x is 0, and e to the x is never 0. It's always above 0, because remember the graph looks like that. Okay, so f is always increasing. because f prime at x is always greater than 0. Explain why the inverse exists and find its expression. Well, if it's always increasing, it's crossing the horizontal line test. Okay? So, and now we have to find the expression. So we're going to have x equals e to the y minus 1. Not e over. So e to the y plus 1. So cross multiplying and getting the y's all on one side and everything else over. So we're going to have so x e to the y minus e to the y equals negative x minus 1. And if I I'll do that. So e to the y and then x minus 1. And I'm just going to factor out this. And then we'll have e to the y equals negative x plus 1 over x minus 1. And if we write it logarithmically, we're going to have log base e of negative x plus 1 over x minus 1 equals y, so the inverse. Okay? So, 25. F at x is that. Find the stationary points and determine their nature. So we would use product rule on this. So du is 2x minus 1 to the 1, and dv is 3x minus 4 squared. And chain rule is just multiplying by 1 on both. So we're going to have f prime is u times the derivative of v plus the derivative of u times the derivative, times v. And if we factor out an x minus 4 squared, that's going to be 3x minus 1 squared plus 2x minus 1, and we need one more x minus 4. So then we're going to have 3x squared minus 2x plus 1. And that's x squared minus 5x plus 4. And then we're going to have 3x, well, I'll just do it all at once. 3x squared plus 2x squared is 5x squared. Then we're going to have negative 6x minus 10x. And we're going to have 3 plus 8, which is 11. And then we should hopefully be able to factor this because they want us to find the stationary points. So we need 11 and 1 here. And we need negative and negative. So that's 5x squared minus 5x minus 11x, which is the negative 16x, and then plus 11. So that means our critical points are x equals 4, x equals 11 fifths, and x equals 1. I am not going to do second derivative. I'm just going to do first derivative into this one. So we have 1, we have 11 fifths, which is 2 1/5, and we have 4. So our points are 0 into the first derivative, 2, 3, and 5. So 0, well, the first thing's always squared, so it's always positive. So here we're going to have a negative times negative, so this is positive. 2, we're going to have negative because we're going to have a positive and then a negative and a positive. 3, we're going to have positive. and 5 also positive. So stationary points, we've got those, and their nature. So x equals 1, because it's going positive gradient, negative gradient, is a max. At 2 1/5, so at x equals 11/5, we've got negative to positive is a min, and x equals 4 is just a stationary point. Okay, so this one is the previous one, so we do have to find the second derivative. So, if that's the first derivative, we need, I'm just going to use this one. So we're going to have first times the derivative of the second, which is 10x minus 16, plus the derivative of the first, which is this, times the second. And then we have to set that equal to 0. It says with graphing calculator. So when we put it into the graphing calculator, we can do, okay, so I'm putting in x minus 4 squared times 10x minus 16 plus 2x minus x minus 4, and then times 5x squared minus 16x plus 11, and you get you get a graph, and you have to find the zeros. So that's at 1.465. We have another one at 2.935. And we have another one at 4. So when, so we need to check in the second derivative, but we've got a graph, which is great. So these are our zeros, and we need to check on either side. So 0, and then 2's in the middle there, and then 3, and then 5. So you can just do graph trace on your graph, but you can also just see what's going on. So at 0, it's negative. At 2, it's positive. At 3, it's negative, and at 5, it's positive. So all of these are points of inflection, actually, because they're all changing. They're all changing concavity. Okay, so it goes from negative concavity to positive concavity. So these are all points of inflection. Okay, 27, consider f at x equals that. Find the derivative. So we're going to have 2x plus, nope, because this is plus px to the negative 1. So we're going to have minus px to the negative 2 is the derivative. There's a minimum when x is negative 2. So we would set this equal to 0. So basically, there's a minimum at negative 2. So we're saying the derivative at negative 2 equals 0. So we've got 2 times negative 2 minus p over negative 2 squared equals 0. So that's negative 4 minus p over 4 equals 0. So negative 4 equals p over 4. So p is negative 16. Okay, this is the function. x greater than or equal to b. Show that f prime is that. So we are going to have v and v squared on the bottom. All right, so v times the derivative of u minus u times the derivative of v. So this is 2x squared plus 12 minus 4x squared over x squared plus 6 squared. So that's negative 2x squared, or 12 minus that, over x squared plus 6 squared. Hence, find the smallest exact value v for which the inverse function exists. Okay, so we would set this equal to 0. Cross multiplying, we're going to have 12 minus 2x squared equals 0. So 12 equals 2x squared is 6. So x equals plus or minus root 6. So this is saying there's a min or a max at these two values. So we will, if we want it greater than or equal to b, it's going to be the positive root 6. So this graph looks like, well, not so jagged there. Something like this. So here, it's not crossing, or it's not passing the vertical line test. So this is going to be negative root 6. That's the minimum. And here's the positive root 6. So if we restrict it past that, it's passing the horizontal line test. So, yeah, it'll just be the positive of that, because if it's negative of that, even if you don't know what the graph looks like, if it's greater than something, you have to take the larger of the two.